In this example, we're going to be dealing with a pen that does not work. Hold on a second. With a tangent function. So you'll see it asks for the tangents. Come on, wake up. There we go. The tangents of phi plus beta. And then I'm going to use what information I'm given here. In this case, cosine of an angle and the location of that angle. And cosine of another angle and the location of that other angle. And you know what? I'm going to color code these things. We're going to keep track of it a little better this way. So I'm going to have angle beta in blue and angle phi in red. And let's just get started drawing triangles for these things. Similar procedure to what we've done before. And I look at the red angle phi and I think, oh, 3 pi over 2 to 2 pi. That's quadrant 4. So we just draw a triangle over here. Does not have to be accurate. Just stick in a reference angle and we are good to get started. Okay, this must be 6 to the right over 7 if you know your SOHCAHTOA ratios. So there's part of the triangle, and if you use Pythagorean's theorem, we can say 6 squared plus, well, I'll call that b. 6 squared plus b squared equals 7 squared. So that becomes 36 plus b squared equals 49. So that means b squared equals 13, which means b equals plus or minus the radical 13. Which one of those makes sense? This is a question for you, and you have to use your intelligence as a trigonomicist to figure this out. I'm going to say negative makes sense because we are going down. Okay, this is a negative y value. So there's the completed triangle for phi. Now we move along. I'm going to do the same procedure for beta. We're going to do this one a little quicker. Quadrant 2, there's my triangle. Here's my reference angle right there. I see, yep, that's negative 1/2 right here. So cosine, negative 1/2 means negative 1, and a hypotenuse of 2. I'm going to use Pythagorean's theorem here to say that's radical 3 in the vertical direction. Go ahead and prove it to yourself. Say a squared plus b squared equals c squared. You'll see this all works out. I've just done a couple triangles, and I know how these go. Now, I want to use these completed triangles to make this thing. And if you think about what tangent requires, it doesn't require sines and cosines. Tangent of phi plus beta requires tangent of phi, tangent of beta, and 1 minus tangent of phi times tangent of beta. So if I can just get tangent of phi and tangent of beta, we are set. So I'm going to look at this triangle on the right, and let's just say, well, tangent of beta in this case is opposite over adjacent. So that's going to be, let's see, radical 3 over negative 1. Let's just call that negative radical 3. Okay, and on the left, tangent of this one equals what? Tangent of phi equals opposite over adjacent. So that's negative radical 13 over 6. Okay, so let's use these two values here, this one and this one, to inform our equation. So we just plug those in. So here we go. And you know what? I'll just stick with blue. Tangent of phi, that is negative radical 13 over 6. Okay, plus tangent of beta. Well, that one's nice. That's just negative radical 3. It's not a fraction. And then on the bottom, I have 1 minus tangent of phi. That's negative radical 13 over 6 times tangent of beta. Let's use some parentheses to keep these negatives straight. Radical 3. Okay. So we can simplify this a little bit by multiplying those radicals together on the bottom. I'm just going to go one step at a time. But I also know I want to multiply this by a crazy one, 6 over 6, to clear some of those compound fractions. So let's do all this in one step. We've done compound fractions before. This is going to be negative radical 13 minus 6 radical 3 on top. And on bottom, we have 6. Oh boy, 3 negatives. That makes a negative. Okay. The 6 crosses out the 6. Okay, so I don't need to worry about those. And all I have left is radical 39. All right. I don't think anything simplifies. 39 has factors 3 and 13, Those are prime numbers. So it looks like this is as far as I can take it. That would be my answer on this one.